Good morning, grade 9s, and welcome to WorksheetCloud Natural Sciences lesson today. I am so delighted that you could join us. It is great to have you here. If you have a question during the lesson, please can you send an email with your question to grade9@worksheetcloud.com. My name is Mrs. Ernston, and I am the WorksheetCloud Grade 9 Natural Sciences teacher. So, grade 9s, I'm really proud of you at the moment for the control that you have taken of your lessons. I know how difficult it must be for you while you have to stay at home and still try and get into your work and term 2 work, and you're missing your teacher and you want to be with your teacher and ask her questions, and you want to be around your friends and you want to go and play sports. But what I just want to say to you is that no matter how difficult things may seem, you really are showing that it can be done. So please keep up the determination, keep up the motivation. I know it's really difficult at the moment, but I am really proud of everything that you're doing. So grade 9s, please keep it up. Today, we're going to be having a look at balancing chemical equations. So that means, what is a chemical reaction? How can we represent what happens in a chemical reaction? What do the different symbols in a chemical reaction equation mean? What do the numbers in a chemical reaction mean? What does it mean to balance a chemical equation? How can you tell if a reaction or an equation is balanced? And what are some of the rules to balancing equations? So the first thing I want to have a look at here are some terms and definitions around equations. So the first thing, here we have our chemical equation. This arrow represents that a reaction has happened. So here we put our arrow. Everything to the left of the arrow is known as the reactants, and everything to the right of the arrow is known as the products. So in the equation here, these substances here are known as the reactants. Here we have our arrow, which means these substances here are known as the products. So if we take this equation of hydrogen plus oxygen making water, let's go through and see what these symbols and numbers all mean. So that H stands for hydrogen. This O is for oxygen. And the H2O is the chemical formula for water. So we get these symbols from the periodic table. So what do these numbers in the front mean? So here we have a 2. Here I've put a yellow circle, but it's just a space to show that we have an invisible 1. And here we have a 2. So what do we call these numbers? We call these numbers the coefficients. And what they stand for is they stand for the number of molecules. So we have 2 molecules of hydrogen plus 1 molecule of oxygen. They react together and chemically combine to form 2 molecules of water. So the numbers in the front stand for the coefficients, where you don't actually see a number, where it's just a space, just a reminder, that is an invisible 1. So it means 1 molecule. So what are the numbers at the bottom called? So here we have a 2, here we have a 2, here we have a 2, and here we have a space. They are known as the subscripts, and they refer to the number of atoms in 1 molecule. So in 1 molecule of hydrogen gas, I have 2 atoms, because remember, hydrogen is a diatomic molecule. So the same applies to oxygen. Oxygen is also a diatomic molecule. So in one molecule of oxygen, I have 2 oxygen atoms. In one molecule of water, I have 2 hydrogen atoms and 1 oxygen atom. So this blue square is representative of the invisible one. So where there's 1 atom, it just gets left blank. It's an invisible one. The other fact that I'd like you to remember is the law of conservation of mass. So the law of conservation of mass states that in a closed or isolated system, matter cannot be created or destroyed. So it can be changed from one form to other forms, but the mass has to be conserved or is conserved. The mass has to be the same. So how does that relate to what we are currently doing? So any time that atoms separate from each other and recombine into different combinations of atoms, we say that a chemical reaction has occurred. So in a chemical reaction, the sum of the mass of the reactants must equal the sum of the mass of the products. That means all the atoms together of the reactants needs to equal all the atoms together of the products. So the equation needs to be the same. So in a chemical reaction, no atoms are lost or gained. All we do is we rearrange the atoms in a chemical reaction. So a great place to go and have a look is at this website here. So you can pause the screen and you can write down the name of the website. It has got great online simulations of balancing equations, but I will be having a look at this in 3 lessons time. We'll be working on this online program together. But if you're interested in this and it excites you, get the web address down and just put it into your internet browser and it should take you to the website. You may need to download the program, but it is a wonderful creative space to learn about balancing equations. But if you're unable to do that, please don't worry. I will look at it in round about Friday's lesson. We'll be having a look at this simulation, so keep tuned. So if we have a look at this diagram, this is a ball diagram representing this equation. So the small white circles represent hydrogen atoms. So 1, 2 hydrogen atoms, and that represents 1 molecule. So there's 1 molecule of H2, there is another molecule of H2. So there 2 refers to the number of molecules. 1 molecule, 2 molecules. H2 represents 1 H atom, 2 H atoms. Then these red balls represent oxygen. So oxygen there is O2. So there are 2 atoms of oxygen, but they have chemically combined. So there's they're not chemically combined, they've just combined into 1 molecule. So now hydrogen and oxygen chemically combined. There is a chemical reaction. And here I have 1 molecule of water, and here I have another molecule of water. So that is why there is 2 molecules of water here. So again, if we have a look at the number of atoms, in 1 molecule, I've got 2 hydrogen atoms, 1, 2 hydrogen atoms, and 1 oxygen atom, 1 oxygen atom. But here I have 2 molecules. So just to test your understanding, let's take away the chemical reaction with the symbols and let us see if you are able to work it out. So remember, this arrow represents a chemical reaction. These are the reactants to the left, and then to the right, these are the products. So how many H atoms on the left of the reaction. So remember, the white circles are H atoms. So we have 1, 2, 3, 4. How many H atoms are on the right of the reaction? 1, 2, 3, 4. How many O atoms on the left? So that is the red circle. 1, 2. How many O atoms are on the right of the reaction? The products. 1, 2. So we then say that this equation is balanced because there are the same amount of hydrogen atoms in the reactants as the product. So the sum of the atoms on either side of the chemical reaction are the same. And back to the equation. It's balanced. H2O2 plus O2 gives us 2 molecules of H2O. So here's an activity for you to do on your own. So I'll read through it with you. The black atoms are carbon, and we represent the element carbon with a symbol C. So this represents carbon, and that represents carbon. And the red atoms are oxygen, and oxygen, we represent that element with the symbol O. So this red dot is oxygen, that's oxygen, that's oxygen, and that's oxygen. So what do I want you to try and answer? What kind of representation is this? So is it macroscopic, submicroscopic, or symbolic? So remember, macroscopic means you can touch it or see it or feel it. So can you actually touch the carbon and touch the oxygen? Submicroscopic means that we imagine what we think the atoms look like. And using symbols means using letters and words to represent the reaction. I want you to write a symbolic representation. So for example, I want the chemical equation for the above reaction. I want you to write the formula for the reactants. So remember, here's the arrow indicating a chemical reaction. Everything to the left is the reactants. I want you to write the formula for the product of this reaction. So here's our chemical reaction. Everything to the right is a product. So I want you to write the chemical formula for that. Then I want you to count how many carbon atoms are on the left side of the reaction and how many are on the right. Then I want you to count how many oxygen atoms are on the left side of the reaction and how many on the right. And then I want you to be able to tell me, is the equation balanced? And why do you say that? So please, can you pause the video now and answer these questions? Right, let's see how you did with answering these questions. So what kind of representation is this? It is submicroscopic. We are imagining what we think the molecules look like. If we want to represent this using words, we're going to say carbon plus oxygen. The arrow shows the chemical reaction, gives us carbon dioxide. We represent carbon by the letter C, symbol C, plus oxygen with the symbol O, the line representing the chemical reaction, and then the compound CO2. So remember, carbon, it's an invisible one. Carbon is only one atom. There is one atom of carbon. Oxygen, we write it as O2 because there are two atoms of oxygen. CO2 is made up of one carbon atom and two oxygen atoms. So write the formula for the reactants of this reaction. Remember, these are to the left of the arrow. So it's C plus O2. Write the formula for the products. CO2, products to the right. Count how many carbon atoms are on the left side. There's one. on the left. And how many on the right? 1. Count how many oxygen atoms are on the left side of the reaction. 1, 2. How many on the right side of the reaction? 1, 2. So is this reaction balanced? Yes, it is. And why do we say that? Well, the sum of the atoms in the reactants is equal to the sum of the atoms in the products. So therefore it is balanced. So it will be a good idea if we could write a definition for a balanced equation. You're probably not going to be asked this definition in a test or exam, but if you are asked it, at least you have it. I think the important thing here is that you understand what we mean by a balanced equation. So a balanced equation is an equation for a chemical reaction in which the number of atoms for each element in the reaction is the same for both the reactants and the products. So it means the sum of the mass of the atoms in the reactants must equal the sum of the mass of the atoms in the products. So let's have a look at this picture here. This is a sparkler. And if you have a look carefully in the diagram, you can see sparks coming off the tip of the sparkler. So that means we are having a chemical reaction happen here. So when magnesium metal burns an oxygen, we can write the following word equation for the reaction that occurs between these two elements. Now, when we have a sparkler, there are lots of different metals that are used to make up the sparkler. But in this instance here, I am assuming that in this sparkler with the bright white sparkles, we are assuming that the metal used to make the sparkler is going to be magnesium. So when we light the sparkler, the magnesium in the sparkler is burning in the oxygen. So let's see if we are able to write this equation. So magnesium plus oxygen gives magnesium oxide. So what are the products? What are the reactants? What are the products? Can the word equation be changed into a chemical equation? And is this equation balanced? So please pause the video now and answer these 4 questions. So firstly, let's have a look to see if we can draw the diagram. So the word equation, magnesium is burning in oxygen. That's the reaction. Here's the metal magnesium. It's burning in oxygen. Okay, and what happens is we make magnesium oxide. So let's represent magnesium with a purple dot. Oxygen we'll represent with a red dot. So that means magnesium oxide is made up of 1 magnesium atom and 1 oxygen atom. So what are the reactants? The reactants, here is the line, the arrow that's showing the chemical reaction. Reactants are to the left. So magnesium and oxygen are reacting. What is the product or products? In this case, there's only one product. It's magnesium oxide. Can you change the word equation into the chemical equation? So according to the periodic table, magnesium is Mg, oxygen is O, and if we put them together, we make magnesium oxide, which is MgO. Remember, the reason why oxygen is written as O2 is oxygen in its natural state is diatomic. So is this equation balanced? Which means, are the atoms the same number on either side? So here we have 1 magnesium atom, and here we have 1 magnesium atom. But here we have 2 oxygen atoms, but here we only have 1 oxygen atom. So the number of atoms on either side of the equation is not balanced. So how on earth do we go about balancing this equation? So what you can do in your books is you write down the equation like this. And through the next few lessons, I'm going to show you several different ways that you can balance an equation. There isn't only one way. You need to try and work out a way that suits you, that helps you understand. So sometimes you're taught to draw up a table like this. So in your books, you'll write down the chemical equation, and underneath it, you will draw up a table that looks like this. So you write down the number of atoms, okay, and then you write down reactants and products. And then if we have a look at this equation, the elements that we have magnesium here and oxygen here and oxygen here. So the 2 elements that we have in this chemical reaction is magnesium and oxygen. So the reactants, we've got 1 atom of magnesium and 1 atom in the reactants, and we have 1 atom of magnesium in the product. So we write 1 and 1. Then if we go to oxygen, in the reactants we have 2 atoms of oxygen, and in the product we only have 1. So we need to get this table to balance. So now I'm going to go through a step of reasoning, and let's try and see how can we get this balanced? What method can we follow? So we need to now balance this chemical equation. So that's what the chemical equation looks like. So it's Mg plus O2 is MgO. So we know that it's unbalanced. So then, can I do this? So if this is the original reaction, can't I just add another oxygen atom onto the end here? And then it will be balanced. Because look, here we have 1 magnesium. Here's 2 oxygen, and here we have 2 oxygen. So can I just add another atom to that molecule? So then if we write this symbolic equation for that, it's going to be Mg plus O2 gives us MgO2. MgO2. Now, I can't do that because I don't have MgO here. I've got to have MgO. I'm not allowed to change this. So I don't have MgO. Now, I've actually changed the chemical formula from MgO to MgO2. So magnesium oxide to magnesium dioxide. So I've actually changed the compound. So that means we have changed a subscript in the formula. I have changed one of the atoms at the bottom here. And this is one of our first rules. You cannot change the formula of a compound when balancing chemical reactions. So we're not allowed to change the subscript. Okay, so if we want to balance our equation, this can't work. Okay, so there's our equation. Okay, what if I just do this? What if I just add another oxygen atom onto the end? So that means I have Mg plus O2 gives me MgO. So I haven't changed the compound, but I balance it out just by adding another oxygen. So then I have 2 magnesiums, and I have 1 magnesium on the reactants, 1 magnesium on the products. 2 oxygen atoms on the reactants, and I have 2 oxygen atoms on the products. Yay, my equation is balanced. Can we do that? Okay. You are also not allowed to add single atoms to either side of the equation. It is the second rule in balancing equations. So you can't just go and add it because I'm actually changing the chemical reaction. So I've got to keep this chemical equation and chemical reaction as is. I can't be adding extra atoms. So remember that we may only use the chemical formulae that are already in the equation. So I may only use Mg, I may only use O2, and I may only use MgO. I'm not allowed to change that. So what we've got to do is we've got to balance the magnesium oxides out with the one oxygen here, two oxygens here, and one magnesium here. Or basically, we've got to balance the one magnesium here and the two oxygens here with this here. Which means we can only change the coefficients. So that's what we had at the beginning. If we have a look here, how does this look? So I've got MgO, and what I've done is I've just added another whole molecule. So look what we've done here. I've still got Mg, Mg, O2, O2. So I haven't changed that. I haven't changed the chemical formulae either. I've just added another whole molecule. Okay, so when we have a coefficient in the front, that means I have 2 atoms of magnesium, and 2 atoms of oxygen. So there's 2 atoms of magnesium, there's 2 atoms of oxygen. So by adding another molecule, I have now balanced out the oxygen. But what about the magnesium? Because here I now have one molecule of one atom of magnesium, but now here I have 2 atoms. So what can we do? Well, you just add another whole molecule of magnesium. So we add another whole molecule. So remember, you may add molecules, you may add coefficients, and now our equation is balanced. Here are 2 atoms of magnesium this side, and there are 2 atoms of magnesium this side. Here are 2 atoms of oxygen this side, and there are 2 atoms of oxygen this side. I have not changed the formula. I have not added atoms on either side. All I have done is I've changed the number of molecules. So this is quite a complicated way to balance equations, but I've just represented it like this to show you what some of the rules are. So maybe you just want to recap for yourself, what are some of the rules when balancing equations? So a few important rules for balancing chemical equations. Bullet number 1. When we balance reaction equations, we may only add coefficients to the chemical formulae that are already in the equation. We may not change the chemical formulae of any of the reactants or products by changing the subscripts in the formulae. We may not add other reactants or products, so this includes adding single atoms of any elements that are already in the reaction. You may also not remove any reactants or products. So you can pause the video now and you can write down these 4 important rules for balancing equations and keep them ready, keep them handy, because we'll need to refer to them in the coming lessons. So let's just recap what we know about the chemical reaction of hydrogen with oxygen to make water. So here we have hydrogen, 1 molecule of hydrogen that's made up of 2 atoms, 1 molecule of oxygen that's made up of 2 atoms, and 1 molecule of water that's got 2 hydrogen atoms and 1 oxygen atom. Okay, so we can represent this by drawing it. So here are 2 hydrogen atoms, 1 molecule of 2 hydrogen atoms. Here is 1 molecule of 2 oxygen atoms. Here is 1 molecule of water, H2O. So how do I go about balancing this equation? Remember, we can only add molecules. So on this side of the equation, I have 2 hydrogen atoms, 1, 2. And on this side of the equation, I have 2 hydrogen atoms, 1, 2. So hydrogen is balanced. What's not balanced is oxygen. So here we have 2 oxygen atoms, and here we only have 1. So in order to balance it out, I can add another whole molecule of water. Okay? And if we do that, let's see how it changes the reaction. So I have 2 oxygen atoms on the reactants, and I have 2 oxygen atoms on the products. But in adding another molecule of water, what have I done to my hydrogen? Here in the reactants, I've got 2 atoms of hydrogen, but here I now have 1, 2, 3, 4. So how can I solve this by only adding a molecule? Well, what if I add another molecule of water? So here now we have 1, 2, 3, 4 hydrogen atoms that are on the reactants, and we have 1, 2, 3, 4 in the products. For oxygen, we have 1, 2 atoms in the reactants, and in the products we have 1, 2. So I haven't changed the coefficients, I haven't added atoms, I haven't changed compounds, I haven't changed subscripts, but I have changed the coefficients here. So there's another way that we can now balance chemical reactions. And what we do here now is we skip out doing the ball diagrams. Okay, so that was just to help you along. So what do we do if I give you the chemical reaction like this? Well, underneath the chemical reaction, you can draw a table. So I just like to draw a line down the middle where the chemical reaction is, and I like to write the names of the elements in the reactants and the names of the elements in the product. So everything this side of the line is the reactants, and everything this side of the line is the product. So in the reaction here, I have H and O, so I write H and O. In the products, I have H and O, so I write H and O. And then I go and count the number of atoms. So hydrogen has got 2 atoms, oxygen has got 2 atoms. Here, hydrogen has got 2 atoms and oxygen has got 1 atom. So how do we go about changing it? So hydrogen is balanced, but oxygen is not. So we've got 2 oxygens this side. So how can I change it? Well, we'll just add an extra water molecule, which means now that we don't have 1 molecule of oxygen anymore. We now have 2 molecules of oxygen. Okay, so that's now balanced. Yay. But wait, what have we done by putting a 2 in the front? What have we done here to the hydrogen? So we now actually have 4. So 2 times by 2 is 4. So now we actually have 4 more atoms of hydrogen this side. So now my equation is unbalanced. So what can we do? So if you add another molecule of hydrogen, we go 2 times by 2, that's now 4. So now our equation is balanced. In our reactants, I've got 4 hydrogen atoms, and in the products, I've got 4 hydrogen atoms. In the reactants of oxygen, I've got 2, and in the products of oxygen, I've got 2. So we now have a balanced chemical equation. So let's just practice one more. If we have the equation Mg plus O2 is MgO, so we're going back to our sparkler. How are we going to balance this equation? So I have a hint. It's not a rule for you, it's just a hint. Always start with the metals and always leave the hydrogens or oxygens for later. So I'll write out my chemical equation, and then I put a line down where the arrow is for the chemical equation. And then I write down the atoms of the reactants, so Mg and O, and there's 1 magnesium atom and 2 oxygen atoms. And then for the products, I write underneath the products, I write down the elements Mg and O, and I have 1 Mg atom and 1 oxygen atom. So if we have a look at it and we start with the metal, that's great. Our metals are balanced. So we don't have to do anything to the magnesium, but let's have a look at the oxygen. Here I have 2 atoms of oxygen, and here I have 1. So what can I do? I can add another molecule of MgO. So what will that do? That will mean I now no longer have 1 oxygen atom because I've now got 2 molecules. So Invisible 1 times by 2 gives me 2. So I now have 2 oxygen atoms. But in the process of adding another molecule, I have added another magnesium. So now I have 2 magnesium atoms, invisible 1 times by 2. So even though now my oxygen is balanced on either side, if we have a look now, magnesium is not balanced. I now have 2 atoms of magnesium and only 1 atom of magnesium on the reactants. So what do we do now? Well, add another molecule of magnesium. So if you add another molecule of magnesium, that now means I have 2 magnesium atoms that are reacting, and I have 2 magnesium atoms in our product. I have 2 oxygen atoms in the reactants, and I have 2 oxygen atoms in the products. So our burning magnesium and oxygen, our sparkler reaction is now balanced. So this is a tricky one that you can try. So let's go through it step by step. So we have methane plus oxygen gives us carbon dioxide and water. You are never going to have to learn this equation off by heart. I am just challenging you in the last few minutes of this lesson. So if we have a look at our hints, the first thing we do, we put a line down where the reaction is, and we write out the elements that are parts of the reactants, and we write down the elements that are part of the products, and we write down how many atoms in each. So carbon has got 1, hydrogen has got 4, oxygen has got 2. So those are our reactants. Then with our products, carbon is 1, hydrogen is 2. But have a look carefully at the oxygen now. We find it in 2 places. So there's one oxygen atom here and 2 oxygen atoms together. So you've got to add 2 plus 1 gives us 3. So with the ruling, I've said start with a metal first, but now there isn't a metal in this equation. So go to the next non-metal. So it's going to be carbon. Leave the hydrogen and oxygen till later. So if we have a look here, wow, carbon is balanced. Okay, so then let us go and have a look at hydrogen. So why did I pick hydrogen and not oxygen? The reason why I picked it is if we have a look at the product, oxygen appears in 2 places. And it can get a little bit tricky, so leave it for last. Oxygen only appears once in the product. So let's start, hydrogen only appears once. So let's start sorting out the hydrogen. So here, this side of in the reactants, we have 4 atoms of hydrogen, and here we have 2 atoms of hydrogen. So how can we go about fixing this? We now put 2 molecules in the front here. So 2 molecules now means that, so carbon is now balanced, hydrogen is now balanced. But what have I done in adding another molecule here? What have I done to the oxygen? I've added another 2 oxygen atoms. So I don't have 3 oxygen atoms anymore. I actually have 4 oxygen atoms because I've got the 2 oxygen atoms here plus now another 2 oxygen atoms here. So let's see, what do we still need to balance? Carbon is fine. Hydrogen is balanced. So let's have a look at oxygen. Here we have 2 oxygen atoms, but here we have 4. Remember, 2 from here and then 2 from here. So how can we balance this out? Well, if we put another molecule of oxygen in here, 2 times by 2 now gives us 4. So we now have 4 oxygen atoms. So our equation for methane combining with oxygen giving us carbon dioxide and water is now balanced. And there is the ball diagram for you to help. So just to hint when doing these chemical equations, start with a metal. If the metal is not there, then look at the non-metal. Okay, and then if you sit with the case, now we've got hydrogen or oxygen, which one do we pick? the element where there is only one element on that side of the reaction. So if we have a look here, we only find hydrogen once, but I find oxygen twice. We'll start with the hydrogen first, and then please always remember, leave the hydrogen and oxygen for last. This little activity here you will find in the worksheet for today's lesson, and I will elaborate more on it in tomorrow's lesson. So if we have a look at iron reacting with oxygen, so we have a metal reacting with oxygen, here's a little word problem for you to solve. When iron rusts, it is because the metal oxide reacts with the oxygen in the air to form iron oxide. So you can pause the video and you can write this question down. So just to highlight a few things for you, when iron rusts, it is because the iron metal reacts with the oxygen in the air to form iron oxide. So what I'd like for you to do is write the word equation and convert the word equation into a chemical equation. Then, depending on your confidence levels of balancing equations, you then may need to convert the chemical equation to a picture equation. So if you need this visual stimulation, then follow through with step 3 of drawing the picture. Then redraw the diagram so that it's balanced. Remember, you can only add molecules. And then convert the balanced picture into a chemical equation. Now, for some of you, you've got a handle on balancing chemical reactions and you're confident about it. You can skip out steps 3, 4, and 5. And you can just jump straight to balancing the chemical equation using a table format. So you can pause the screen now and you can try and do this activity. If you're struggling, please don't worry. I'm going to explain it in tomorrow's lesson. And another challenge for you today, I would like you to write down the important rules for balancing chemical equations, and I challenge you with solving and trying to balance the chemical reaction here. So stay tuned for tomorrow's lesson and the remainder of the lessons this week. They're all going to be covering balancing equations. So if you struggle to understand things, please, one place you can go is this FET Colorado online simulations and balancing equations, which I will use the simulation on Friday's lesson. These are the topics that we covered today. So hopefully you are feeling a little bit more confident in how to balance a chemical equation. So again, I just want to reiterate how I am so proud of your motivation, your determination, your perseverance, your dedication, your never give up, don't give up attitude. So I look forward to a week of balancing equations with you. So stay tuned, keep up to date, and remember that today's lesson was brought to you by WorksheetCloud and Grade 9s. I'm so glad you could join us today. And if you have any questions, please email grade9@worksheetcloud.com. Bye.